Hi and welcome to another Carpenter Tutoring tutorial. I'm Amy and today we are going to talk about the different properties of addition, their names, what they mean, and some examples of how they get used. Now, a disclaimer for this particular topic is that in your day-to-day math work, you don't really actually need to know the names of these different properties. There may be a chapter in your book or a unit in your class that requires you to say, oh, I can do this because of the commutative property, or I can do this because of the inverse property. But once you move past that chapter or unit, no one's ever going to ask you the name of these. So the important takeaway here is more so what these properties mean and how you can use them in addition problems, even if you don't remember the names of each. So I'll use the names in case you're in that particular chapter or unit where you have to know them. But if you're beyond that chapter and just looking for a refresh, the important thing to remember are the different things we can and can't do within addition problems because of these properties. We'll start out with a commutative property. It's a bit of a tongue twister of a name, but this reminds me of the word commute, which means to move around. And that is exactly what this property is all about. The commutative property tells me that changing the order of numbers in an addition problem does not change the sum of those numbers. So for example, if I have 3 plus 5, well, that's the same thing as 5 plus 3. Even if we get multiple values involved in this addition problem, 1 plus 2 plus 3, for example, I can order these any way that I want to and still have the same outcome because all the values that I'm adding together are identical. It doesn't matter the order that they come in. Our next property is the associative property. I like to think of this one as being social and coming together. We can kind of hear that word social in associative. And so what this property tells me is that if I have a problem with all addition, that's a very important part of this property. It has to be all addition. So every operation is addition, but I have some values trapped inside parentheses. Let's say something like 5 plus 3 plus 7. What the associative property tells me is that the location of those parentheses doesn't actually matter. So even if I wrote this as 5 plus the quantity 3 plus 7, my sum would still turn out to be the same. Another way of thinking about this is that if you have parentheses in a problem where your only operation is addition, those parentheses are actually meaningless because they're not separating any different operations. So we can remove those parentheses and make this 5 plus 3 plus 7, which then takes us right back to a commutative property problem, which tells us we can order that addition in whatever way we want to. So whether you think about this as being able to move the parentheses and change what numbers are trapped within the quantity, or thinking about this as removing the parentheses entirely and treating it like a commutative property problem, the takeaway is that we can move these numbers around and start with whatever combination we want to, so long as we end up adding all values together. Up next, we have the identity property. For the identity property, I think of being true to yourself and staying true to who you are, staying unchanged, right? So this is the property that tells us what we can do with addition to stop a number from having any sort of change. Sounds a little bit funky, but once we see it on paper, it'll make sense. The identity property of addition tells us that if we add 0 to any value, that value won't change. So if I have 5 and add 0, I'll still have 5. If I have 7 and add 0, I'll still have 7. And if I have 1,364 and add 0, I'll still have 1,364. So what this is telling us is that numbers stay true to themselves or keep their same identity, even if you're adding a value of 0 to them. So another way of thinking of this is that adding 0 does not change numbers. So adding 0 does not have an impact on the value. Finally, the inverse property of addition starts to talk about negative values and tells us how we can always create a sum of 0. So the inverse here makes me think of opposite, and that's really what this property is about, opposite numbers on opposite sides of 0. So what this tells us is that for every number, we could say something like 6, if I add its opposite, which in this case would be negative 6, I'll get a sum of 0. This holds true even if we start with the negative number. So if I start with a negative value like negative 18 and add its opposite, which would be positive 18, I'll still get a sum of 0. So the main idea here is that adding the positive version and the negative version of the same value will always give us a sum of 0. I hope it's been helpful to go through some of the different properties of addition, both what they mean, what they allow us to do, and their names if you're in a unit or chapter that requires you to answer with those. As always, if you have any other questions or topics that you'd like to see covered, please let me know down in the comments. If you enjoy our content, I hope you'll consider liking this video and subscribing to our channel. Thank you so much for spending part of your day with me, and I'll catch you next time.